Today we will start with work. What is work? So first of all, what is work? Work means any kind of mental and physical activity. Work means any type of physical and mental, that is work. In our daily basis life, we can relate work as a reading of book, cooking of food. But in physics, if we relate the term work, it means mechanical. Now this mechanical work in physics is said to be done if body is replaced due to the application of force. Work is said to be done, body is displaced due to the application of force. Now conditions which must be satisfied to be work done. Satisfied to be work done. First condition is there must be a force. The force must act on a body. Second is the body must be displaced. The body must be displaced from one position to another position. Now, definition of work done. Work is said to be done by a force on a body or an object if the force applied causes a displacement in the body or object. Now example of work done is, we can take some example of work done. Work is done when a ball is dragged on the floor of one position to the another. Work is done when a box is dragged on the floor from one position to the another. In this case, force is on the box is to drag it on the floor and the box moves through a certain distance between one position to the another position. Now we can measure the work done. So the next topic of ours is a measurement of work. Measurement of work. Work is measured by the product of force and the displacement in the direction of force. So work is an scalar quantity. So work is equals to force into displacement in the direction of force. So work done is equals to F T cos theta, as if we plot if if the displacement is in the x direction and force is and some inclined angle theta to that displacement, this force is inclined to the displacement d, then if we take a projection of this displacement on the force vector, then we get d cos theta as a displacement as a projection of displacement d, and we got this formula: work done is equals to force into displacement cos theta. In other matter, in other diagram, we see if we make this displacement as same as in the direction x-axis, this is d, and force is applied to an some inclined angle theta, and if we take the projection of this force on this displacement d, we got f cos theta. So the formula becomes work done is equals to d f cos theta, which is work done. Now there are some special cases in the work done. To find out the work done, special cases are there. Case 1. If theta is equals to 0 degree. If theta is equals to 0 degree, it means the direction of displacement and the force makes an angle of 0 degree. Means both are in the same direction. If we calculate the work done, then Fd cos theta is the formula of the work done, and theta is equals to 0, and we all know that cos 0 is equals to 1. Cos 0 equals to 1. So work done is equals to Fd, which is maximum. When force and displacement are in same direction, then work done will be maximum. When force and displacement are in same direction, then work done is maximum. Now case 2. Case 2 is when theta is equals to 90 degree. Means it was at a right angle to the force. So if we draw a diagram, here is displacement and force will act at 90 degree to this displacement. Then what is the effect of the work done? So work done is equals to Fd cos theta. Here cos theta is cos 90. We all know that cos 90 is equals to 0. So work done is equals to Fd 0, which will equal to 0. So work done when a force is applied to a displacement at an angle 90 degree is 0. When a force and displacement are perpendicular to each other, so we can conclude that when force and displacement are perpendicular to each other, then work done will be 0. Now example of this you can give as if a body is moving in a horizontal direction. Suppose we have a body of mass m placed on the surface, and the displacement of this body is in the direction horizontal direction, and the gravity is acting on the body is at 90 degree to it. So displacement is in the horizontal direction and gravity is in the vertical direction. So the total work done on this body is 0. Total work done on this body is 0. If we take next example of if a body is moving in a circular motion. So body is in a circular path, then work done by the centripetal force will be 0. Because the direction of centripetal force is towards the center, centripetal force is acting towards the center and center of the circle, and the displacement which along the tangent. Displacement in the circular path is along the tangent. So the angle made by both of them is 90. Force is applied here, which is centripetal force. So we can say that work done will be 0. Now we take case 3. What is case 3 of condition of the work done when theta is equals to 180 degree? When theta is equals to 180 degree, work done can be given as FD cos theta, then FD cos 180, and cos 180 is equals to -1. So we can given that work done is equals to minus FD. When the force and displacement are in the opposite direction, then work done will be negative. So we can conclude that when a force and displacement are in opposite direction, then work done will be negative. Now we move on. We get units of work done. What are the units of work done? Means units of work. If we talk about the SI unit of work done is work is given as force, which is meter per second square, and distance is given as 1 meter. So in combined, work done can be given as in SI unit is equals to 1 joule. Joule is a SI unit of work. If we come to CGS unit of work, then it will given as erg. Now we define one by one what is joule and what is erg. If the force of 1 Newton is applied on the body, the displacement in the body is 1 meter in the direction of the force, then the work done is the 1 joule. If the force applied on the body is 1 Newton, displace the body 1 meter, then the force, then the work done is given as 1 joule. Now like this, if we define CGS unit of work, then it will be given as if 1 Newton force is applied on the body, makes a displacement of 1 centimeter, then the work done is 1 erg. Now work done can be a positive or a negative work done. So first we define what is a positive work done. Positive work done when an angle between the force and the displacement is acute, which is theta is smaller than 90 degree, then work done will be positive work done. Because one component of force F cos theta is in the direction of displacement, so work done by the component will be positive, FD cos theta. Work done by the vertical component F sin theta will be 0, and the angle between F sin theta and displacement is 90, so work done by the phi will be positive. If the displacement was in direction, if a block is placed on a surface, force is applied inclinedly to the surface, which makes an angle theta, and displacement is in direction, then if we take a projection of this force, it will give F cos theta, and a component of force is in y direction, which is F sin theta. So F cos theta gives a positive force because because positive work done because it will in the direction of the displacement and makes an angle theta is equals to which is both are displacement and the force F cos theta is in same direction, so they makes a positive work done. Now negative work done. Negative work, we can define negative work done when an angle between the force and the displacement is obtuse, means theta is greater than 90 degree. So we can say that the work done will be a negative because work done by the horizontal component of force F cos theta is negative, which is minus Fd cos theta, and the work done by the vertical component F sin theta will be 0, and the net work done will be negative. So if body is placed and displacement was in direction to the surface, horizontal to the surface, and force is applied obtusely, means theta is greater than 90, and we get the component of this force, we get F cos theta in the opposite direction and F sin theta vertically perpendicular, and this angle is theta. So F cos theta can be written as F cos 180 minus theta. So this angle is 180 minus theta. This angle is 180 minus theta. So we can say that this F sin theta is perpendicular to the displacement, which cause no effort on the work done, and this F cos theta is negative because 180 cos 180 minus theta is minus cos theta. So resultant is work done is minus F cos theta into D displacement. So it will be known as a negative work done on the basis of this.